Have you ever heard the name Henri Poincaré? Probably not as often as Einstein, right? But what if I told you that this French genius, a mathematician, physicist, and philosopher, came breathtakingly close to discovering the theory of relativity before Einstein? This is the story of the man who laid the groundwork, connected the dots, and stood on the very precipice of one of the greatest scientific revolutions in history, only to have another name etched into our textbooks forever. Let's rewind the clock to the late 19th century. Science was in a state of beautiful chaos. Physicists were grappling with a major puzzle, the speed of light. Decades of experiments, most famously the Michelson-Morley experiment, had shown something incredibly bizarre. No matter how fast you were moving or in what direction, the speed of light always measured the same. This completely defied classical physics, the world of Isaac Newton, where speeds should simply add up. If you're on a train moving at 50 miles per hour and you throw a ball forward at 10 miles per hour, someone on the ground sees it moving at 60. But with light, it was as if you were on that train, shone a flashlight, and both you and the person on the ground measured the light beam moving at the exact same, mind-boggling speed. It made no sense. This is where our hero, Henri Poincaré, enters the scene. He wasn't just another scientist scratching his head. He was one of the leading mathematical minds of his era, often called the last universalist, because his expertise spanned so many fields. Poincaré looked at this experimental mess and saw a pattern. He saw a deep underlying principle at play. In a landmark speech in St. Louis, Missouri in 1904, a full year before Einstein published his famous paper, Poincaré laid out what he called the principle of relativity. What was this principle? He boldly proposed that the laws of physics must be the same for all observers in uniform motion. This means that no experiment you could possibly conduct inside a smoothly moving, windowless spaceship could ever tell you if you were moving or standing still. This was a radical idea, and it was the foundational pillar upon which relativity would be built. He was the first to give this concept its name and to treat it as a fundamental law of nature. But Poincaré didn't stop there. He was also wrestling with the concept of time itself. He was fascinated by how we synchronize clocks. Imagine trying to synchronize a clock in Paris with one in New York using telegraph signals. The signal takes time to travel, right? Poincaré realized that you have to account for this travel time. He then took a giant leap of imagination. He concluded that because the speed of light is constant, observers moving relative to each other will fundamentally disagree on whether two events happen simultaneously. He called this local time. For one observer, two lightning strikes might seem to hit at the exact same instant. But for another observer, flying past in a rocket ship, one would strike before the other. Time, Poincaré realized, wasn't absolute. It was relative to your state of motion. This is a monumental insight. The idea that simultaneity is not universal is one of the core counterintuitive concepts of special relativity. Poincaré was right there. He had the pieces. He understood that our measurements of space and time must be flexible and interconnected to keep the speed of light constant for everyone. He even used the mathematical tools, known as the Lorentz transformations, which are the very equations that describe how space and time warp and stretch at high speeds. He saw that these transformations formed a perfect mathematical group, hinting at a deeper, unified structure of spacetime. So he had the principle of relativity. He had the relativity of simultaneity and the concept of local time. He was using the correct mathematical framework. Why isn't he the one we picture with the wild hair and the Nobel Prize for relativity? The answer lies in philosophy as much as in physics. Poincaré, for all his brilliance, was a traditionalist at heart. He saw all these strange effects, time dilation, length contraction, as mathematical tricks or conventions. He believed there was still a true time and a true space, even if we could never measure them. The local time was just a convenient mathematical tool to make the equations work, not a description of physical reality. He was trying to fit these revolutionary new ideas into the old framework of a fixed, luminiferous ether, a hypothetical medium that was thought to fill all of space and carry light waves. He was patching up the old theory, not building a completely new one from the ground up. Then, in 1905, came the miracle year. A young unknown patent clerk in Bern, Switzerland, named Albert Einstein, published a paper titled On the Electrodynamics of Moving Bodies. Einstein started from the same two basic principles as Poincaré, the principle of relativity and the constancy of the speed of light. But here's the crucial difference. Einstein took them as absolute, unshakable postulates about the physical world. He didn't try to explain why. The speed of light was constant. He simply said, "Let's assume it is, and see what happens." From these two simple starting points, Einstein fearlessly followed the logic, no matter how strange the destination. He didn't see local time as a mathematical convenience. He declared that it was physical time. Your clock literally ticks slower when you move faster, relative to me. He didn't see length contraction as an illusion. He showed that a moving meter stick is physically shorter in its direction of motion. He completely abandoned the idea of the ether, declaring it superfluous. He wasn't patching an old house. He was demolishing it and building a skyscraper in its place. He reforged our understanding of space and time into a single, unified entity, space-time. And as a final flourish in a short addendum paper later that year, he derived the most famous equation in all of science, E=mc². He showed that mass and energy are two sides of the same coin, a direct consequence of his new theory. This was the final critical step that Poincaré never took. While Poincaré saw the shadow of relativity on the wall, Einstein turned around and saw the object casting it. He provided the complete physical interpretation, the revolutionary shift in worldview that changed science forever. Does this diminish Poincaré's contributions? Absolutely not. Science isn't a race where only the first person across the line matters. It's a collaborative construction project, with many people laying the foundation, erecting the scaffolding, and fitting the pieces together. Poincaré was the master architect who drew up the most detailed and advanced blueprints. He cleared the path, identified the key principles, and developed the necessary mathematical tools. Einstein was the visionary builder who saw how to put it all together in a completely new way, creating a structure more profound and elegant than anyone had imagined. So the next time you hear the name Einstein, maybe take a moment to also remember Henri Poincaré, the brilliant mind who stood at the edge of reality, pointed the way, and gave us a glimpse of the universe that was about to be revealed. He's a powerful reminder that sometimes the greatest discoveries aren't just about finding the right answers, but about having the courage to ask the right questions and to accept the revolutionary nature of what you've found. Thanks so much for watching. It's a fascinating story, isn't it? If you enjoyed this deep dive into the history of science, please hit that like button and consider subscribing for more stories about the hidden figures behind the science. Let me know in the comments what you think. Did Poincaré deserve more credit? See you in the next video.